Alright, so begins part 2. Basically what I've got with this Wavetek now, why is all this disconnected, is a mod issue. And what I mean by that is the audio from the FM mod on this is not very good. Let's see, what do I need to do here? Power it up. Generating 150 megahertz, 1 kilohertz mod at about 5 kilohertz deviation. Let's see. Going into my deviation meter right here. Waiting on it to lock. Remember, it's still cold, so it'll lock here in a minute. It should lock here in just a second. As soon as it does, we should be able to get an audio reading here, and I'll show you what I'm talking about. But while I'm waiting on this thing to lock, the output of the signal generator is being fed into my modulation meter right here under FM 5 kilohertz, and then the AF is coming out going over to my scope. So I'm just waiting on it to lock, and by the looks of the scope, it's getting there. It should be there any minute. I have some of the BCD switches unplugged. I guess I can plug them back in. I don't think that makes a difference because it will work with a couple of them out, because they're always see if I can break one. Come on now, lock. There we go. It hasn't quite locked yet. There we go. It's locked. There it is on Sweet B right here. Let me sync it to B. Where's my signal? There it is. That right there is the 1 kilohertz. See, it's more trapezoid than anything else. So I'm going to reduce the mod. Matter of fact, let's turn channel 1 off. I want to bring that up a little bit and get a whole lot better. So it's at 5 kilohertz right now. According to that, there's 5 kilohertz. See, as I reduce the level, see it turn into a trapezoid there, just about. Turn it back down. Now it looks right. Turns out that is coming out of this modulation board right here that we worked on previously, and I noticed on the last video as I was reviewing it that I wasn't showing the schematics very well. I apologize. I thought it was good. Apparently it was not. But the modulation that we're looking at within the oscilloscope right here is exactly the same as the output mod. So whichever the problem is back this way. So I did some scope measuring, and it's not easy. That's not easy to get to. This circuit right here, it's an MC 1458 op amp. So anyway, the 1000 hertz mod comes in through this selector right here, goes into this mod control, which is on the front, goes into this MC 1458, and comes out FM1 or FM10. So it's distorted. It's clean coming in right here, but it's distorted coming out, which means it looks like I'm overdriving this, and I'm not 100% sure that I actually have a problem. But I didn't have I didn't have the op amp, so I ordered one from Mouser. So I'm going to turn this back up to 5 kilohertz deviation. I don't think this is going to be the fix, but what I'll do is I'm going to pause you for a minute, and we'll change that IC, and we'll go from there, see what happens. Alright, you haven't lived until you tried to put an integrated circuit into a socket using a pair of tweezers. Anyway, let's see what happens. I either got the wrong chip, or I put it in backwards, or it's going to work, and if it does work and not blow up, it probably didn't fix the problem. And let's find out. Gotta wait on this to lock. I'm kind of thinking that when I was playing around with the reference oscillator, not the reference oscillator, but the main oscillator that interacts with the reference oscillator, that it was, I think that might have been the problem with this thing not locking properly. In other words, when I changed, because I have not been able to duplicate it since I was playing around with the adjustments on that that card, right? Which one was it? M29? This one, I think. Anyway, waiting on it to lock. It's kind of squirrely when it's not locked. I didn't think it was supposed to put any output out when it wasn't locked, but oh well. It's getting there. Waiting. See, it's going to make all this anticipation build up, and then it's going to make you wait, and then when it does work, you're going to see that it probably didn't fix nothing. But we'll just wait and see. I guess while we're waiting, this thing here, when I bought it off of eBay, it was very low sensitive. I mean, it took a lot of signal to get this thing to work. It turns out, after a lot of troubleshooting, it turned out there was a ring mixer inside here. It made a little bitty coil, a little ring mixer coil, and that thing had little rubber insulation on it to each leg. It had 4 connections, I believe, and but that insulation, that rubber, had decomposed, and it ate into the copper of the little transformer, and it wasn't mixing properly, and so it made the sensitivity really bad. And anyway, I was able to repair the coil, and this thing works like a champ now. Still ain't locked, huh? Still waiting on you. I'll bring you back in the size of lock. Okay. Well, much to my amazement, we're set on the front panel for 5 kilohertz FM deviation at 1 kilohertz mod. This is right at 5, but look here, it's not trapezoid anymore. It is a pretty little sine wave. Would you know? I mean, what can I say? I'm really flabbergasted. That's pretty. That is what it should do. This thing ain't sounded good in a long time. So, found a bad chip. Wow. How about that? So that's 1000 hertz. And let's see, cursors, let's do 1 second. Let's see. Yeah, according to my scope, right on the button. Close enough for government work. So, that problem is fixed. Let's switch over to 400 hertz. There's 400 hertz. That looks good. I'm going to raise the level up. Going back to 1000. I've raised the limit up to, what do we got here? At 15, 10, 9, 8, I'm about 7 kilohertz deviation. It still looks nice. I would say that was a success. We'll bring it up to a full 10, which it's right on the button, right there on 10. Look at there. That is awesome, is it not? So let's go to times 10. So 10 times 10 is 100. So let's go to 15. Let's go to times 10. And let's go 2 times 10 on this. It should be 100% mod. It almost is. Look at that. And look at that. How about that, boys and girls? We successfully repaired that part of the problem. So now we've got our DC mod pot fixed. We got our locking. Locking's still a little slow on this, but we got the vernier working. Let's see. We got the mod cleaned up, which looks decent now. The output level seems to be pretty close. Wow, I'm surprised. And the output sounds clean too. Basically, I didn't do nothing more. Well, I mean, we turn the mod off and look. Go to DC. See, still something's not quite right. See, I placed it to mod. Yeah, there's still an alignment issue on this thing. But the output of the detector looks clean. There's no noise there that I can see. So we're getting progress here. So it's really all I have time for today. So yeah, it was that MC1458 chip right there. This is part of it right here, and this is part of it right here. So it was that chip that was bad for whatever reason. So that is a success. Let's give it some FM times 1. Let's go down here back to 5. Yeah, I feel good about that. We're gonna go back to times 1. We're gonna go back to 5. That is just beautiful. Beautiful. Very good. Let's hear what it sounds like. I'm just going to take this right here. As you can hear on my radio, that sounds good. That sounds good. And still a little touchy on that frequency synthesis. It really wants not quite where it wants to be. So I think that's going to be the next thing. is looking into that. But hey, we got the mod going. That's the biggest thing. We got the mod cleaned up. Sounds really good. I was hoping so, because I really didn't know which way to go if that was it. There's nothing in those circuits. Those are relatively simple little op-amp circuits. Unless there's a resistor off or something like that. There's no capacitors. So it had to be the IC. And it was. So it's a success. So I'm going to shut down this video. This is going to be a relatively short video compared to the first one. The introductory video, if you want to call it that. Probably going to go through the alignment, the FM alignment back on this thing again. Probably what I need to do next, so I don't have a whole lot of time today, so might be a part two. So anyway, I will bring you back. Bye. Okay, we're still on part two. I decided to move on with this simply because I want to. I was looking in the manual. I moved a few things around. Let me turn you around. I moved everything around, so let's go to wide. The manual does not say we don't need to get out of sequence. We have done the we started the calibration procedure here, and I'm using the Wavetek book. It just makes more sense than the military version that's in the back of this thing. Anyway, we've done the plus 18 volt, the minus 18 volt, the plus 7.3. We did the crystal frequency adjustment, which I think we're fine on that. Let's see, we've done all that. Now we got the 5.3.5 phase lock loop adjustment, loop 1 adjustment, M31A. No adjustment of module 31A is necessary. Well, hey, I like that. Now 5.3.6 says phase lock loop 2 adjustment, M32A. So the M32A is this dude right there, and it's got 1, 2, 3, 4 controls on the top. Of course, I'm going to have to get the schematic and find the M32A. But let's see. It says see figure 5.5 for location of M32 test points, or figure 5.6 for adjustment controls. So we need to find 5.6. See. No clue. So instead of me leafing through this stuff, acting like I don't know where nothing is, I'll bring you right back as soon as I find this stuff. Okay. Alright, I had to do a little digging. So what we're looking for here, again, I had to use my pointer. We're looking at figure 5.5 for location of M32 test points. So for that card there, we're going to look on this right here. Hang on a second here. Still ain't got my stuff together. Anyway, so here is the bottom view of the device. Here is M29.2. Was it M29.2? I'm sorry, M32A. I'm a dork today. M32A is this one right here. And we have 1 and 2 here, if you can see that. 1 and 2. So 1 is frequency adjust, which is this one. And then 2 is PLL2 test point. So here's the 32 right there. I've got some kind of scribbling on there. So I guess M32, so the third one down. Let's see, so here's 32, so it says third one down. Does it not? It says it, yeah, it says here third one down. So that's got to be a test point. Okay, so that is test point 1, which is the frequency adjust. Okay, and then 2 is right beside it, and it's the PLL2 test point. So this is frequency adjust and PLL2 test point. So let's see what that involves. Let's change it over to 5.5 right here. 5.5 M32. As soon as y'all see it, y'all tell me. Here we go. Right there, number 12. There it is. A and B. Now that M32 don't quite match my M32, but I'm gonna go with it. Anyway, here we go. Let's see. Every pointer I get. M32. I lost it again. Here we go. M32A. 0 megahertz adjust, 39 megahertz, and then so A and B. And I don't know what that C is. I guess C is, yeah, unlock indicator. So this one shows 2 in an unlock indicator. And as you can see, this one's a little different. What the difference is, I do not know. So I think before I do anything else, I'm going to look. You know what? Let's just do it. So I'm gonna put you on a tripod. Okay, we're back. We're still trying to do the phase lock loop 2 adjustment M32A module, which is this guy. In case I didn't show it right, this guy. So I'm set the lever indicator switches to 200 megahertz. So let's come over here, 200 megahertz, and it locked. Let's see, we also need to set all other front panel controls that's in section 534. Here we go, 534. So we set frequency vernier calibrate, which is this one here. Modulation mode, continuous wave, CW. Alright, modulation frequency external. Okay. Modulation FM AM minimum. Output vernier fully counterclockwise, output step attenuator at plus 10 dBm. My mod meter don't like that, so I'm not doing it. Meter function output. So here we go. So where's my pointer? So everything is done. Connect a digital voltmeter, which is this dude, to M32 pin 14. And if we come over here, this is the M32, so this is 16, 15, 14 right there. So connected to that test point 14, or pin 14. So what we want to do now, carefully adjust both the crystal reference trimmers A and B to provide a minimum reading on the voltmeter. Okay. Minimum reading on the voltmeter. Voltage should be between 0.5 and 3 volts. So I guess we'll just play with these pots. Hope for the best. That way just let you look. Let me dick around with these. Yeah, you can see the meter. Okay, well, here goes nothing. I don't know what the hell I'm doing. Well, there's another one that does absolutely freaking nothing. Yep, neither one of them did a damn thing. Ain't that special? So, I'm not going to ruminate about this, so I'll bring you back as soon as I figure out what the hell happened that time. More problems. Could be I'm on the wrong test point. Let me see. Hang on. I don't know. Let me research it. I'll be back. Well, run into a little minor snag. Go figure. I turned the thing off because the board does not match. None of this matches. The board is not marked properly. Imagine that. So, I've turned the rig off. I'm going to take it out of the board and I want to dissect it and figure out what does what. And whenever I figure out something, I'll bring it back.